Exponentiation of the function
S
is
3.141572.
Check.
Riemann integral of the
function
function
s cube x.
while you have been introduced to calculus. So first principle is actually the first way you could approach differentiation, and it's a very, very simple way if you understand the process. Okay, so I'm going to be giving the general formula, and also I'm going to be giving you some basic workings you can do with this formula so you can be able to understand your first principle very well. So before you proceed, don't forget to like, share, subscribe to this channel so you can see more videos when they drop every Mondays. All right. So the first principle is dy over dx is equal to the limit of the change in x as it tends to 0, okay, then the function with a small change, that means x plus change in x minus f of x, then all over change in x. Now the common mistake students make is to think that change in x and dx that they're the same. No, this is very, very wrong. Change in x is different from dy over ds. Now dy over ds is a total derivative, while change in x is just an increase or a decrease in the measurement or in the parameter you are working with. Okay, so let's take for example, let's assume that you want to solve, you can be asked to do y is equal to 3x using first principle. You see, using first principle, how are you going to do this? So you are going to say dy over dx is equal to the limit. It's actually very simple once you can get the glimpse of this. Now this f x plus dx means that anywhere you see x, just change it to x plus dx. So I'm going to have 3 into x plus what? Change in x, okay? Minus 3x. That's your fx, which is your function, over change in x, okay? So I'm going to have dy over dx is equal to the limit change in x tends to 0. So I can decide to actually open the brackets. So I would have 3x plus 3 change in x minus 3x over change in x. Okay, so of course you see some of them can cancel out. This cancels this. Okay, so I would have dy over dx is equal to the limit change in x tends to 0 into 3 change in x over change in x. And you can see that change in x also can cancel out. This cancels this. So I'm left with what? Dy over dx is equal to the limit of x change to x tends to infinity into 3. Of course, there's no change in x here, so our final answer for dy over dx will be what? Will be 3. This is actually a very simple example to start with. We're actually going to do more complex ones as we move on and as we drop subsequent videos. So let's check another example. Should in case I'm too fast, you can pause the video to check step-by-step approach and to understand what exactly you're doing. Let's say we want to do y is equal to something longer. Let's do 2x squared plus 3x minus 1. So again, our formula is what? Dy over what? Dx is equal to the limit of change in x, change 0, then f x plus change in x minus f of x over what? Change in x, which denotes anywhere you see x in your function, you should put what? X plus change in x. Okay, that means I'll have 2 into bracket what? X plus change in x raised to power 2 plus 3x plus what? Change in x, then minus 1. That's just your f of x, so plus change in x. So I'll now do minus, the whole function, 2x squared plus 3x minus 1. I actually did it in a different color so that we can really understand the difference between these functions. So if I'm to open this, I'm going to have dy over dx is equal to 2. Don't forget your limits actually. I'm have my limits changing x to 0, then I will have 2 into, I have x squared plus 2x changing x plus changing x squared. Okay? Then plus 3 x plus changing x minus 1. Then minus open everything. I have minus 2x squared minus 3x then plus 1. Everything divided by what? Change in x. Actually very simple. So let's clear this part off so we can have a clear sheet to work with. Okay. Now we have dy all over dx is equal to the limit of changing x tends to 0 into, I can open the bracket, so 2 times x squared, I will have 2x squared plus 4x change in x, okay, plus 2 into change in x squared, that's for that, then plus 3x plus 3 change in x minus 1 minus 2x squared minus 3x plus 1 all over change in x. So of course you can see some common terms that can actually cancel out there, like this can cancel this one. Which other one? This can cancel what? This one. Pay attention. This can cancel this one. So I'll be left with dy over dx is equals to the limit of changing x tends to 0 will be 4x changing x plus 2 change in x squared, then what? 3 change in x over 3 over change in x. All right, so in that case, let's clear out this one. We have, now you see that dx is common here, it's common here also, and it's common here. So I can actually factorize it out. I will have dy over dx into my limit as x dx tends to 0, then I will have dx into 4x plus 2 change in x plus 3, okay, over change in x here. So what do? We strike out change in x. So what we are left with now, actually we are left with dy, okay? We're left with dy over dx is equal to the limit as change in x tends to 0. We have 4x plus 2 change in x plus 3, which means that anywhere you see dx, change in x, put what? 0. So I have dy over dx is equal to 4x plus 2, put a 0 because we have dx here, okay? Put 0, then plus 3. So my dy over dx is equal to 4x plus 3. And that's the final answer. And of course, if you want to check, you can see that if you bring down this one to multiply your 2, you have what? 4x, then minus 1 from here, that's 4x, then plus what? Plus 3. And that's the same thing with this one. So that's how to do your first principle. In subsequent video, we are going to be solving complex questions, still using first principle, so you can know how to approach your questions whenever you see them. And don't forget to like, share, subscribe, and also tell your friend about this channel, so that as video drops, you get to learn every week, every time. And until then, make sure you keep solving, make sure you keep reading, and make sure you keep doing math.